Superheat relative to heating and air conditioning, HVAC, etc., split units for a residential home perhaps. One may wonder, when one starts to read the gauges, they wonder what, or perhaps one may wonder what the telltale signs of high superheat, low superheat, optimum superheat, etc. If one looks at the gauge here, say if the pressure is low, say around 50, if we come over here, if we're using an R22, which is the green refrigerant, and we reference 50 between here, this reads between 30 and 20. So we're going to say 20 and 30, we're going to say 25. So we're going to say the gauge temperature says 25. The PSIG says 50. So we know we have on the low pressure side, we have a low pressure, and it's below freezing. So if we take the formula for superheat, a little quick assessment, and we say superheat, perhaps line minus gauge, and we take these numbers. Say if the gauge outside says if we have the clamp, the temperature clamp affixed to the copper line, say the larger copper line, there should be a larger and a smaller. The larger one sometimes has insulation on it. Say if it's 75 degrees hypothetically, the gauge temperature is 25, which we referenced over here. We notice that the pressure is low. So once the pressure is low, it appears that the temperature, according to the gauge, may be low too. If one notes it's below 30, so anything below 32 is sitting there, it's in the freezing mark, 32 or below. So if we're saying 20 and 30, half of 20 and 30 would be, say 25. So if we subtract 25 from 75, we have high 50 superheat is 50. That's extremely high. An optimum superheat, generally speaking, may be between, say, around 15 degrees superheat. So if you go outside in the summertime and you note the copper line with the insulation, hopefully it has the insulation, all of a sudden you notice ice or frost build up on the insulation, and then the frost set you're either, well, you've got a couple problems perhaps. Either one could be airflow, two could be a low refrigerant charge. So when the gauges are hooked up, these are the numbers we come up with. 50 is extremely high. So if we have a high superheat, which may mean that there may be a low charge. Well, why would a high superheat? Simply because the gauge tells us 25, and if the line's 75 and we take the difference here, that's 50. We want this number here to be in the range of somewhere around 15 degrees, plus or minus a few degrees, perhaps, to have optimum level. So if we have to push this up, if we're at 25 degrees, the system starts to freeze. And once it starts to freeze, the airflow gets blocked, so it's in a sort of a hypothetical. It's in an infinite loop, because the more ice, the less airflow. Creates more ice, less airflow. So more ice. So the ice. One tech support guy conveyed one time that once you see ice out at the condenser outside, oftentimes the system may be frozen up in the air handler. So it's frozen up in the air handler at the A coil, which may be the evaporator coil. It's frozen up there first, and it's working its way all the way out. So a high superheat. So when we add refrigerant, say if it were an R22, or someone adds refrigerant, not necessarily we, but hypothetically, and then if you start to bring the PSI up and bring the number up, and this is the reason a high superheat could indicate a low charge. So if we bring this number up to below 30, we see right here we're 32 degrees. So if we bring this up to 100 PSIG, and we reference this at 60, and then we plug 60 into this number instead of 25, then we would say that may be 75 minus 60, which that may come up to, say, 75 minus 60, that would that would be maybe 15 degrees superheat. So it tells you that the higher the pressure. Now, you don't want to get it too high, but it needs to be balanced. It needs to be fine-tuned. But once the pressure is in this range, but the pressure needs to be higher when you reference it across from here, that it's above 32 degrees. 40 to 50 degrees may be a good temperature range to be in hypothetically speaking. So, but if we're down to a charge of 50, which is low refrigerant, that means we're down below freezing, and then we're susceptible to having the system to ice up. So in order to get the correct refrigerant charge, at least charge it, in my opinion, above the amount PSI, to where when one references it, it's at least above 32 degrees, preferably around 40, 45, 50 degrees, somewhere thereabouts. So then one may say, well, if you have high superheat, how does this indicate ice? That doesn't sound right. Well, if it's a mathematical thing. If we reference this as 25 degrees here, and this is 25 degrees, then, okay, if we take 75 degrees minus 25 degrees, there's a 50 degree difference. That tells you that's the reason it would be a high superheat. If we get the gauges up to a number, say 100, and we have 60, and we plug 60 in here, then the superheat number is going to be, say, around 15, somewhere thereabouts. So this is kind of an indication of how high superheat and low charge, low PSI can indicate a freezing evaporator coil, which eventually could make itself out to the condenser outside. So again, superheat for a HVAC split unit. Hope this makes sense, and have a wonderful day.